Hey, welcome back to Construction Disruption. Normally, I would be traveling around and looking for ways to build faster, cheaper, better. And we do our best to try and capture as much of that as possible. But there's a lot that happens behind the scenes that we don't get to capture, well, at least in high quality. But I still want to show you these pieces because our journey is still about capturing all of our ability to be able to build faster, better, and cheaper. So let's get into it. Normally on the channel, really there are three parts to what we're delivering. And the first part about what we're trying to do is discover, which is what we've been sort of doing. You've seen us travel around, we're looking for innovative new technology, and we're going to try and figure out how to use it. The next is actually using that technology, bringing it back, testing it, figuring it out, just like my printer. I traveled all the way to France. Now we're gonna start using it, and you're gonna start to see how that evolves. Then the final aspect is our 6-story building that we're gonna eventually get to build. Now, I know we're gonna get there and we're gonna use that real equipment with that real testing and that real discovery and everything that we bring together. Hopefully, that allows us to build faster, better, and cheaper. In 2025, we spent a lot of time researching different technologies, SIPs, water, 3D printing, and even delved into different aspects of how things are built. This has all led to us buying properties, and this is where we are right now. On our Sixplex building that we're putting together, we know that we're going to be working with some type of 3D printing, and we know that their SIP panels are definitely going to be involved because they add speed and they add viability. But one of the big concerns we have is, what type of floors are we going to use? I started to think that hollow core will work really well with 3D printing. Hollow core slabs are like giant concrete planks with tubes running through them. Now these voids make them lighter, faster to install, yet incredibly strong. You crane them in place and boom, you have a floor that's already fire rated and ready to accept SIP panels. Now I think hollow core is gonna work really well with 3D printing because we need a flat surface and it's fire separated deck right after printing. Now waiting for poured concrete to cure, it would set us back days. But the concrete mass in hollow core gives us a thermal benefit, while SIP panels can sit on top and deliver insulation at speed. Now this layering is like building a sandwich, and each ingredient, kind of brings its own flavor. Because no one's mixed these systems before, we still have to see how the trades are gonna work together. Without knowing exactly how to do this, I went to a site where these were already being experimented with, and this is how it went. Cool things is over here. This is cool too. These are modular wall systems that are made of concrete. One of the things that's fantastic about them is the fact that they've literally got all of the information, which gives them each aspect of weight, thickness, height, and a QR code, which tells all of the specifications of each individual wall system and where it probably is supposed to go. This is the future of construction. By having this level of organization, we're gonna be able to propel ourselves even faster into the future and economically to make sure that we can hit the target market that we're trying to achieve globally using technology and using process. Now, one of the cool things is over here, like in all of these caissons and modular caissons and stuff, like these are all like plumbing pylons and stuff like that. This is cool. No more need to frame and organize stairs. They're already pre-finished, ready to go and set based on the sizes that have been pre-coordinated in the drawings. So think of this. It's literally the analogy that we've been talking about, putting things together like Lego. Now, this is the stuff that we're looking for our building. Faster, cheaper, better organized, and hitting all those monikers that we're trying to do. This is the stuff that we want. I'm here with Caleb from Brochure Construction. And one of the really cool things that we get to do right now is we get to look at how SIP panels and hollow core construction is actually coming together. Caleb's actually working with this product for the first time?
Correct, yeah.
Yeah, first time. So why don't you tell us a little bit about what it's like so far working with a SIP panel and a hollow core product together at once?
So the process of this is a little bit different. The thing I did like about all this is multiple steps are done in one simple process. As soon as these walls go up, they are sheeted. They have your insulation in it. Vapor barrier is done with simply caulking all the joints in a normal job site.
So you don't even have to put on any vapor barrier?
No vapor bearing on the inside. So normally speaking, you would put up your walls.
Yeah.
You'd have to go through after the walls are in, empty the studs, do your insulation, and take your vapor barrier and wrap the entire building.
Right.
With this, it's simply peeling the joints. Vapor barrier is done. You're now free to start drywalling the inside, insulation included.
How much does these pieces of hollow core weigh?
Tens of thousands of pounds.
Tens of thousands of pounds. Okay, now this freaks me out even looking at this.
Yep.
How is it holding up against thousands and thousands of pounds of pressure?
So those are the exact same things I worried about, and I'll show you right here, if you don't mind walking here. So initially, when I was first told to start looking into this, those are questions that came to my mind. I saw plywood and foam in between and tens of thousands of pounds sitting on it.
Yeah.
These studs right here are engineered LSLs. An LSL is an engineered designed stud that, unlike typical lumber, is designed to load tens of thousands of pounds with less lumber needed in the wall. So in this panel, legit is just 2 of these LSLs. The middle has 3, the end has 2 as well. So this load bearing wall only has 5 studs in it, yet is designed to hold this massive slab, all load bearing straight down onto the concrete. So anywhere there is weight, it's these LSL studs, not just the foam and the OSB holding the weight.
Wow, but still, the fact that it's a wood and a concrete hybrid structure. What goes in? Is there? Do you have to put a sill gasket or anything in between the wood and the concrete?
In between the wood and the concrete, there is a sill gasket.
Okay, now I got to ask you: is this process, you think, faster?
Depending how you look at it, from which point of view, from a framing aspect, in terms of just framing walls, for me, I would say it's a bit slower. But in the end, as all the walls go up, as I said before, multiple steps are being done with simply one panel going up. There's no then coming back after framing to have to sheet it, to have to insulate.
So it is faster.
It is very much faster in the end. We are the guinea pig for this one. It's a bit of experimental.
Yeah. Well, it's experimental across the nation right now.
Yeah. For everything lining up, as you said, and being true, it is more difficult than traditional framing because once it's installed, once it's prefabricated, you can't make any adjustments to it. With traditional framing, you can move a stud over, you can bump a wall over. Once you have weight on these walls, it is a bit more difficult to 100% align. In the end though, once you have your first floor nice and plumb, it's a matter of just leveling up everything from there, which what made these other floors even faster is once these walls we were happy with it, there was no more trying to find grid marks, try to find this line, find that line for our wall placement. It was simply just level up the rest of the wall.
And I noticed using these SIPs, they give you a nice 90 corner. So you're not worrying about any type of problems as far as like, you know, trail lines or running off, you know, an inch over or a quarter or over 50 feet. Like,
and they all connect very nice. Actually behind here, to guarantee that, is another set of 2x6 lumber nailed to this wall. When this comes in, it runs smooth. You nail it to it, you have a nice 90-degree angle. Nothing running long, nothing running short.
No, that's fantastic, man. That's really, really cool. Caleb is learning and his team is experimenting and working with hollow core for the first time. I found this insight really valuable. And there was also a lot of modular building components that I found interesting on site. I've seen pre-manufactured stairs in there as well.
Yes.
Okay, how does that line up working with the rest of your modular products that you're bringing in?
So that usually gets subbed off. We have another company that comes and does all of the concrete stairs, all the concrete walls. You see that's a sub that works through us as well.
Yeah.
They come in, they do all their concrete walls, they lay in their concrete landings, and these prefab stairs fit perfectly inside. So again, all weight is connecting to this landing. All the weight is connected to the foundation down below. Everything. Interesting once you actually get to work with it, how everything actually clicks together to bear all of the weight as a whole and as a group. Even though Caleb is working on this and getting the answers to how this all comes together, there are still a lot of things he doesn't know.
So if you were to say, again, now I'm not gonna be able to comment on this, you may not be able to, but cost-wise, like, do you say this is a more efficient from a cost perspective? Like if you're, I know you're not the developer or the guy paying out the dollars, but from your perspective of doing the work and being the guy who's putting this together, from a cost perspective, do you think this is more effective?
I think once a system is given and the proper materials and the proper manpower and tools are given, I believe it will be, because I know wood to a certain extent is cheaper than concrete. You're able to deal with it on site, make some adjustments as need be. Overall, the expense of it, a little above my pay grade to actually know, but I feel like with the proper tools and the proper manpower, it can be very effective. 100%
coordination.
Having a system beforehand saves a lot of prep work. So if you're able to prep ahead of time, which thankfully we've been able to do on these floors. Second floor, we had probably 90% of the material already prepped before first floor is even done. Third floor is also already prepped. So being able to prep ahead of time, having a plan, definitely makes it very productive. Otherwise, you have many guys sitting around waiting for the plan to happen. Whereas beforehand, you have your plan, you have your process, you communicate it,
And with
Runs a lot more
good
smoothly.
efficient products, you're going to be able to hit that good, fast, cheap, choose all three scenario.
100%.
That's amazing. Brochure Construction has been absolutely fantastic for letting us on their site today. I just wanted to say this has been really fantastic. Thank you, Caleb, for the
Absolutely.
interview
Good to meet you.
and letting us know about this product and how we can use it. We're definitely going to be looking forward to using this in the future. So after today of reviewing hollow core, it's really made me think to myself, do I need something this robust for a sixplex? Now, on a 6-story building, this makes perfect sense. It's big, it's powerful, it's fast, and it's cost effective. But for something like a 6-story building, that makes sense, but on a sixplex, is it worth doing? Or should I just use something traditional, like this traditional floor? Comment section's open. You guys let me know what you think. Hit that subscribe button, hit that like button. We'll see you guys on the next show. Now, I gotta figure out where those plumbers went because they've left me to clean up all their mess.